Chapter 6 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Greg Bell. Curiosities of the Sky by Garrett Serviss. Chapter 6 Explosive in Whirling Nebula. One of the most surprising triumphs of celestial photography was Professor Keeler's discovery in 1899 that the great majority of the nebula have a distinctly spiral form. This form, previously known in Lord Rosse's great Whirlpool Nebula, had been supposed to be exceptional. Now the photographs, far excelling telescopic views in the revelation of nebular forms, showed the spiral to be the typical shape. Indeed, it is a question whether all nebula are not to some extent spiral. The extreme importance of this discovery is shown in the effect that it had upon hitherto prevailing views of solar and planetary evolution. For more than 3/4 of a century, Laplace's celebrated hypothesis of the manner of origin of the solar system from a rotating and contracting nebula surrounding the Sun had guided speculation on the subject, and had been tentatively extended to cover the evolution of systems in general. The apparent forms of some form of the nebula which the telescope had revealed were regarded, and by some are still regarded, as giving visual evidence in favor of this theory. There is a ringed nebula in Lyra with a central star, and a planetary nebula in Gemini bearing no little resemblance to the planet Saturn with its rings, both of which appear to be practical realizations of Laplace's idea, and the elliptical ring surrounding the central condensation of the Andromeda Nebula may be cited for the same kind of proof. But since Keeler's discovery, there had been a decided turning away of speculation another way. The form of the spiral nebula seems to be entirely inconsistent with the theory of an originally globular or disk-based nebula condensing around a sun, throwing off or leaving off of rings, to be subsequently shaped into planets. Some astronomers, indeed, now reject Laplace's hypothesis in toto, preferring to think that even our solar system originated from a spiral nebula. Since the spiral type prevails among the existing nebula, we must take any mathematical theory of the development of stars and planetary systems from them accord with the requirements which that form imposes. A glance at the extraordinary variations upon the spiral which Professor Keeler's photographs reveal is sufficient to convince one of the difficulty of the task of basing a central theory upon them. In truth, it is much easier to criticize Laplace's hypothesis than to invent a satisfactory substitute for it. If the spiral nebula seem to oppose it, there are other nebulae which appear to support it, and it may be that no one fixed theory can account for all the forms of stellar evolution in the universe. Our particular planetary system may have originated very much as the great French mathematician supposed, while others have undergone, or are now undergoing, a different process of development. There is always a too strong tendency to regard an important new discovery, and the theories and speculations based upon it, as revolutionizing knowledge, and displacing or overthrowing everything that went before. Upon the plea that Laplace only made a guess, more recent guesses have been driven to extremities, and treated by injudicious exponents as the solid facts at last. Before considering more recent theories than Laplace's, let us see what the nature of the photographic revelations is. The vast celestial maelstrom discovered by Lord Rosse in the hunting dogs may be taken as the leading type of the spiral nebula, although there are less conspicuous objects of the kind which perhaps better illustrate some of their peculiarities. Lord Rosse's nebula appears far more wonderful in the photographs than in his drawings made with the aid of his giant reflecting telescope at Parsonstown, for the photographic plate records details that no telescope is capable of showing. Suppose we look at the photograph of this object as any person of common sense would look at any great and strange natural phenomenon. What is the first thing that strikes the mind? It is certainly the appearance of violent whirling motion. One would say that the whole glowing mass has been spun out with tremendous velocity, or that it had been set rotating so rapidly that it had become the victim of centrifugal force, one huge fragment having broken loose and started to gyrate off into space. Closer inspection shows that in addition to the principal focus, there are various smaller condensations scattered throughout the mass. These are conspicuous in the spirals. Some of them are stellar points, and but for the significance of their location, we might suppose them to be stars which happen to lie in line between us and the nebula. But when we observe how many of them follow most faithfully the curves of the spirals, we cannot but conclude that they form an essential part of the phenomenon. It is not possible to believe that their presence in such situations is merely fortuitous. One of the outer spirals has at least a dozen of these star-like points strung upon it, some of them sharp, small, and distinct, others more blurred and nebulous, suggesting the different stages of condensation. Even the part which seems to have been flung loose from the main mass has, in addition to its central condensation, at least one stellar point gleaming in the half-varnished spire attached to it. Some of the more distant stars scattered around the whirlpool look as if they too had been shot out of the mighty vortex, afterward condensing into unmistakable solar bodies. There are at least two curved rows of minute stars, a little beyond the periphery of the luminous whirl, which clearly follow lines concentric of those of nebulous spirals. Such facts are simply dumbfounding for anyone who will bestow sufficient thought upon them, for these are suns, though they may be small ones, and what a birth is that for a sun! Look now again at the glowing spirals. We observe that hardly have left the central mass before they begin to coagulate. In some places they have a ropey aspect, or they are like peace gods filled with growing seeds, which eventually will become stars. The great focus itself shows a similar tendency, especially around its circumference. The sense that it imparts of a tremendous shattering force at work is overwhelming. There is probably more matter in that whirling and busting nebula than would suffice to make 100 solar systems. It must be convinced at once that there is no confirmation of the Laplacian hypothesis here. But what hypothesis will fit the facts? There is one which has been claimed it does so, but we shall come to that later. In the meanwhile, as a preparation, fix in the memory the appearance of that second spiral mass spinning beside its master, which seems to have spurned it away. For a second example of the spiral nebula, look at the one in the constellation Triangulum. God, how hath the imagination of puny man failed to comprehend thee! Here is creation through destruction with a vengeance. The spiral form of the nebula is unmistakable, but is half obliterated amid the turmoil of flying masses hurled away on all sides with tornadic fury. The focus itself is splitting asunder under intolerable strain, and in a little while, as time is reckoned in the cosmos, it will be gyrating into stars, and then look into the cyclonic rain of already finished stars whirling around the outskirts of the storm. Observe how scores of them are yet involved in the fading streams of the nebulous spirals. See how they have been thrown into vast loops and curves, of a beauty that half redeems the terror of the spectacle enclosed within their lines, like iridescent cirri hovering about the edges of a hurricane. And so again are suns born. Let us turn to the exquisite spiral in Ursa Major. How different is its aspect from that of the other! One would say that if the terrific coral in Triangulum has all but destroyed itself in its fury, this one, on the contrary, has just begun its self-demolition. As one gazes, one seems to see it in the swift, smooth acceleration motion that precedes catastrophe. The central part is still intact, dense, and uniform in texture. How graceful are the spirals that smoothly rise from its oval rim, and gemmed with little stars, wind off into the darkness until they have become as delicate as the threads of gossamer. But at the bottom of the story told here is the same, creation by gyration. Compare with the above curious mass in Cetus. Here, the plane of whirling nebula nearly coincides with our line of sight, and we see the object at a low angle. It is far advanced and torn to shreds, and if we could look at it perpendicularly to its plane, it is evident that it would closely resemble the spectacle of Triangulum. Then, take the famous Andromeda Nebula, which is so vast that notwithstanding its immense distance, even the naked eye perceives it as the enigmatical wisp in the sky. Its image on the sensitive plate is the masterpiece of astronomical photography, For wild, incomprehensible beauty, there is nothing that can be compared with it. Here, if anywhere, we look upon the spectacle of creation in one of its earliest stages. The Andromeda Nebula is apparently less advanced towards transformation into stellar bodies than that is Triangulum. The immense crowd of stars sprinkled over it and its neighborhood seem in the main to lie this side of the nebula, and consequently have no connection with it. But the incipient stars, in some places clusters of them, are seen in the nebulous rings, while one or two huge masses seem to give promise of transformation into stellar bodies of unusual magnitude. I say rings because although the loops encompassing the Andromeda Nebula have been called spirals by those who wish utterly to demolish Laplace's hypothesis, yet they are not manifestly such as can be seen on comparing them with the undoubted spirals of the Lord Rosse Nebula. They look quite as much like circles or ellipses seen at any angle of, say, 15 or 20 degrees to their plane. If they are truly elliptical, they accord fairly well with Laplace's idea, except that the scale of magnitude is stupendous, and if the Andromeda Nebula is to become a solar system, it will surpass ours in grandeur beyond all possibility of comparison. There is one circumstance connected with the spiral nebula, and conspicuous in the Andromeda Nebula on account of its brightness, which makes the question of their origin still more puzzling. They all show continuous spectra, which, as we have before remarked, indicate that the mass from which the light comes is either solid or liquid, or a gas under heavy pressure. Thus nebula fall into two classes: the white nebula, giving a continuous spectrum, and the green nebula, whose spectra are distinctly gaseous. The Andromeda Nebula is the great representative of the former class, and the Orion Nebula of the latter. The spectrum of the Andromeda Nebula has been interpreted to mean that it consists not of luminous gas, but of flock of stars so distant that they are separately indistinguishable even with powerful telescopes, just as the components of the Milky Way are indistinguishable with the naked eye, and upon this has been based the suggestion that we see in Andromeda in an outer universe whose stars form a series of elliptical garlands surrounding a central mass of amazing richness. But this idea is unacceptable, if for no other reason than that, as just said, all the spiral nebula possess the same kind of spectrum, and probably no one would be disposed to regard them all as outer universes. As we shall see later, the peculiarity of the spectra of the spiral nebula is appealed to in support of a modern substitute for Laplace's hypothesis. Finally, without having any means of exhausting the variety exhibited by the spiral nebula, let us turn to the great representative of the other species, the Orion Nebula. In some ways this is even more marvelous than the others. The early drawings with the telescope failed to convey an adequate conception either in its sublimity or in its complication of structure. It exists in a nebulous region of space, since photographs show that nearly the whole constellation is interwoven with faintly luminous coils. To behold the entry of the great nebula into the field, even of the smallest telescope, is a startling experience which never loses its novelty. As shown by the photographs, it is an inscrutable chaos of perfectly amazing extent, where spiral bands, radiating streaks, dense masses, and dark yawning gaps are strangely intermingled without apparent order. In one place 4 conspicuous little stars, better seen in a telescope than in a photograph, on account of the blurring produced by overexposure, are suggestively situated in the midst of a dark opening, and no observer has ever felt any doubt that these stars have been formed from the substance of the surrounding nebula. There are many other stars scattered over its expanse, which manifestly owe their origin to the same source. But compare the general appearance of this nebula with the others that we have studied, and remark the difference. If the unmistakable spiral nebula resemble bursting flywheels or grindstones, from whose perimeters torrents of sparks are flying, the Orion Nebula rather recalls the aspect of a cloud of smoke and fragments produced by explosion of a shell. This idea is enforced by the look of the outer portion farthest from the bright half of the nebula, where sharply edged clouds with dark spaces seem to be billowing away as if driven by a wind blowing from the center. Next, Let us consider what scientific speculation has done in the effort to explain these mysteries. Laplace's hypothesis can certainly find no standing ground either in the Orion Nebula or in those of spiral configuration, whatever may be its situation with respect to the Grand Nebula of Andromeda, or the Ring and Planetary Nebula. Some other hypothesis, more consonant with the appearances, must be found. Among the many that have been proposed, the most elaborate is the planetesimal hypothesis, of Professors Chamberlain and Moulton. It is to be remarked that it applies to the spiral nebula distinctly, and not an apparently chaotic mass of gas like the vast luminous cloud in Orion. The gist of the theory is that these curious objects are probably the result of close approaches to each other of two independent suns, reminding us of what was said on the subject when we were dealing with temporary stars. Of the previous history of these opposing suns, the theory gives us no account. They are simply supposed to arrive within what may be called an effective tide-producing distance, and then the drama begins. Some of the probable consequences of such an approach have been noticed in Chapter 5. Let us now consider them in a little more detail. Tides always go in couples. If there is a tide on one side of a globe, there will be a corresponding tide on the other. The cause is to be found in the law that the force of gravitation varies inversely as the square of the distance. The attraction on the nearest surface of the body exercised by another body is greater than on its center, and greater yet than on its opposite surface. If the two great globes attract each other, each tends to draw the other out in an ellipsoidal figure. They must be more rigid than steel to resist this, and even then they cannot altogether resist. If they are liquid or gaseous, they will yield readily to the force of distortion, the amount of which will depend upon their distance apart, for the nearer they are, the greater becomes the tidal strain. If they are encrusted without, and liquid or gaseous in the interior, the internal mass will strive to assume the figure demanded by the tidal force, and will, if it can, burst the restraining envelope. Now this is virtually the predicament of the body we call the sun, when in immediate presence of another body of similar great mass. Such a body is presumably gaseous throughout, the component gases being held in a state of rigidity by the compression produced by the tremendous gravitational force of their own aggregate mass. At the surface, such a body is enveloped in a shell of relatively cool matter. Now suppose a great attracting body, such as another sun, to approach near enough for the difference in its attraction on the two opposite sides of the body and on the center to become very great. The consequence will be a tidal deformation of the whole body, and it will lengthen out along the line of gravitational pull and draw in at the sides. And if its shell offers considerable resistance, but not enough to exercise a complete restraint, it will be violently burst apart or blown to atoms, and the internal mass will leap out on the two opposite sides in great fiery spouts. In the case of a sun further advanced in cooling than ours, the interior might be composed of molten matter, while the exterior crust had become rigid like the shell of an egg. Then the force of the tidal explosion, produced by the impulse of another sun, would be more violent in consequence of the greater resistance overcome. Such, then, is the mechanism of the first phase in the history of a spiral nebula, according to the planetesimal hypothesis. Two suns, perhaps distinguished ones, have drawn near together, and an explosive outburst has occurred in one or both. The second phase calls for a more agile exercise of the imagination. To simplify the case, let us suppose that only one of the tugging suns is seriously affected by the strain. Its vast wings produced by the outburst are twisted into spirals by the rotation, and the contending attractions exercised upon them, as the two suns, like battleships in a desperate conflict, curve round each other, concentrating their destructive energies. Then immense quantities of debris are scattered about in which eddies are created, and finally, as the sun that caused the damage goes on its way, leaving its victim to repair its injuries as it may, the dispersed matter cools, condenses, and turns into streams of solid particles, circling in elliptical paths about their parent sun. These particles, or fragments, are the planetesimals of the theory. In consequence of the inevitable intersection of the orbits of the planetesimals, nodes are formed where the flying particles meet, and at these nodes large masses are gradually accumulated. The larger the mass, the greater its attraction, and at last the nodal points become the nuclei of great aggregations from which the planets are shaped. This, in very brief form, is the planetesimal hypothesis which we are asked to substitute for that based on Laplace's suggestion as an explanation of the mode of origin of the solar system, and the phenomena of the spiral nebula are appealed to as offering evident support to the new hypothesis. We are reminded that they are elliptical in outline, which accords with the hypothesis, that their spectra are not gaseous, which shows that they may not be composed of solid particles like the planetesimals, and that their central masses present an oval form, which is what would result from the tidal effects as just described. We also remember that some of them, like the Lord Rosse and the Andromeda Nebula, are visually double, and in these cases we might suppose that the two masses represent the tide-burst suns that ventured into too close proximity. It may be added that the authors of the theory do not insist upon the pulse of the two suns as the only way in which the planetesimals may have originated, but it is the only supposition that has been worked out. But serious questions remain. It needs, for instance, but a glance at the triangular monster to convince the observer that it cannot be a solar system which is being evolved there, but rather a swarm of stars. Many of the detached masses are too vast to admit of the supposition that they are to be transformed into planets, in our sense of the planets, and the distances of the stars, which appear to have been originally ejected from the focal masses, are too great to allow us to liken the assemblage that they form to a solar system. Then, too, no nodes such as the hypothesis calls for are visible. Moreover, in most of the spiral nebula, the appearances favor the view that the supposititious encountering suns have not separated and gone each rejoicing on its way, after having inflicted the maximum possible damage on its opponent, but that, on the contrary, they remain in close association like two wrestlers who cannot escape from each other's grasp. And this is exactly what the law of gravitation demands. Stars cannot approach one another with impunity, with regard either to their physical makeup or their future independence of movement. The theory undertakes to avoid this difficulty by assuming that in the case of our system the approach of the foreign body to the sun was not a close one, just close enough to produce the tidal extrusion of the relatively insignificant quantity of matter needed to form the planets. But even then the effect of the pulse would be to change the direction of flight both of the sun and of its visitor, and there is no known star in the sky which being selected as the sun's probable partner in their adjacent pas deux. That there are unconquered difficulties in Laplace's hypothesis no one would deny, but in simplicity of conception it is incomparably more satisfactory, and with proper modifications could probably be made more consonant with existing facts in our solar system than that which is offered to replace it. Even as an explanation of the spiral nebula, not as solar systems in process of formation, but as the birthplaces of stellar clusters, the planetesimal hypothesis would be open to many objections. Granting its assumptions, it is undoubtedly a strong mathematical framework, but the trouble is not with the mathematics, but with the assumptions. Laplace was one of the ablest mathematicians that ever lived, but he had never seen a spiral nebula. If he had, he might have invented a hypothesis to suit its phenomena. His actual hypothesis was intended only for our solar system, and he left it in the form of a note for the consideration of his successors, with the hope that they might only be able to discover the full truth, which he confessed was hidden from him. It cannot be said that the truth has yet been found, and when it is found, the chances are that intuition and not logic will have led to it. The spiral nebula, then, remain among the greatest riddles of the universe, while the gaseous nebula, like that of Orion, are no less mysterious. Although it seems impossible to doubt that both forms give birth to stars, it is but natural to look to them for light on the question of the origin of our planetary system. But we should not forget that the scale of the phenomena in the two cases is vastly different, and the forces in operation may be equally different. A hill may be built up by a glacier, while a mountain may be the product of volcanic forces or of the upheaval of strata of the planet. N. Chapter 6. Greg Bell, Katy, Texas.